Alright, hello everyone. So we're going to be going through osmoregulation and ADH. So osmoregulation is the control of water and solute balance in the body. In humans, this is achieved through a feedback loop involving ADH and the kidney. So what is osmoregulation? Osmoregulation maintains the osmotic concentration of blood plasma within a narrow range. If the blood osmolarity rises, meaning the blood becomes too concentrated, water must be retained. If it falls and blood becomes too dilute, then water must be excreted. So if blood osmolarity increases, then you need to retain water. Keep the water within the blood. But if the blood osmolarity decreases, then you have to excrete the water. Get rid of the water. Okay, so what is the role of ADH? Osmoreceptors in the hypothalamus continuously monitor blood osmolarity. So that's in your brain. When blood osmolarity increases, for example, after sweating or insufficient fluid intake, there's not much water in your body, so your blood osmolarity increases. The hypothalamus signals the posterior pituitary gland to release ADH, or antidiuretic hormone, into the bloodstream. All right, so that is if we have an increased blood osmolarity. This leads to the hypothalamus detecting this, and then it causes the posterior pituitary gland to release the ADH. All right. So when blood osmolarity decreases, so for example, if you drink lots of water, then ADH secretion is reduced, so less water is reabsorbed and large volumes of dilute urine are produced. So that's if we have a decrease in blood osmolarity, then you will find that there is the same hypothalamus, and then there's also a reduced. So instead of a released, it's reduced ADH. Okay, so this is a negative feedback loop. The response opposes the initial change, returning blood osmolarity to its set point. Okay. The same loop operates in reverse. If blood osmolarity falls below the set point, ADH secretion decreases, water reabsorption decreases, and more dilute urine is excreted until osmolarity returns to normal. So what is the role of the kidneys? The kidney is the effector organ in this feedback loop. The collecting ducts and distal convoluted tubules adjust water reabsorption in direct response to circulating ADH levels. The kidney therefore determines the final urine concentration and volume, directly correcting blood osmolarity. So just remember, kidney equals the effector. So in our previous video, we looked at feedback loops. In this specific feedback loop, kidney is the effector. So to summarize, osmoregulation in humans operates through a negative feedback loop. Rising blood osmolarity triggers ADH release from the posterior pituitary, increasing water reabsorption in the kidney and producing concentrated urine. Falling blood osmolarity reduces ADH secretion, decreasing water reabsorption and producing dilute urine. The hypothalamus acts as a control center, the posterior pituitary as a signaling gland, and the kidneys as the effector.